Hey everyone, welcome to the channel. So today I have brought to you Inorganic Chemistry strategy for the upcoming CSIR-NET June 2020 examination. Now I've also made an organic chemistry strategy for which I will give you the video over here somewhere on the top right corner. You can click the link and watch that video if you haven't already. Subsequently, after this video, I'll also be talking about the physical chemistry strategy. Now coming to inorganic chemistry, let me just give you a brief overview of what I have exactly done. So I have analyzed the last 8 examinations, that is June 2018, December 2018, June 2019. Then in December 2019, there were 2 examinations, one for Assam and one for the rest of India. And then in June 2020 also, there were 2 examinations, one was for Tamil Nadu and then one was for rest of India. And then when we had one exam in June 2021, which was conducted in February 2022, that is this year. So I will tell you about the topics that you can expect in the exam that you really need to prepare, basically must do topics. Some topics which have not been asked previously from since a long time, so they might be asked to you in the exam, so you need to prepare for that. And then I have got to you this very important aspect, that is new insights into the main group bioinorganic and analytical chemistry. So a lot of aspirants struggle with these 3 topics because like main group particularly is very vast. It has some sort of weightage, but then what to prepare and what not to prepare, what to leave out, that is something that is always on the mind of aspirants. So I've brought to you some very good insights. I've done some thorough analysis of these last 8 exams, and for these 3 topics I've got to you some insight. Apart from that, if you have any queries related to the examination, and you want to ask it live, because sometimes in the comment section you do not get a response. So in that case, on Thursday from 9 to 11 p.m., that is tomorrow actually, I am having a live session. Okay, so you can join that session. It's a free session, right? So but you need to use this code SETHI to unlock the session. Okay, it's a free session, and the link to that video is in the description box. So it's a live session from on Thursday, that is 9 p.m. to 11 p.m. Okay, so anyway, now the 2 main pillars of inorganic chemistry are coordination and organometallics. So let us see what are the most frequent or what are the most prominent questions that are asked from these 2 topics. So if I talk about coordination, these are whatever topics I've listed down over here, you cannot afford to miss them out. Okay, this is like the bare minimum that you need to do, and these are very frequently asked in the exam. So I'll start with isomerism, like facial, meridional, uh, and like for example, how many stereoisomers will be there. So isomerism in coordination compounds, linkage isomerism, all different kinds of isomerism, that is something you should be well aware of. Then electron transfer is like a must do. It is asked in each and every freaking examination. Electron transfer and electronic transitions, both these concepts. So electronic transitions like your DD transition, then you should be aware of your Tanabe-Sugano diagrams, orbital diagrams, those kind of aspects. Electron transfer like inner sphere, outer sphere mechanism, you should be very thorough with all electron transfer mechanisms. The questions can also come in relation to the rate of electron transfer. They will give you 4 coordination compounds or 4 reactions, and they will ask you, okay, arrange them according to the electron transfer rate, that which will undergo transfer faster, which will undergo slower, those kind of questions. Then electronic transitions, like what kind of complexes will have a very sharp band, or what is going to be the molar extension coefficient, those kind of questions. Then charge transfer is MLCT, LMCT, typical kind of questions. Please be aware of denticity of ligands, if there are ligands that can coordinate through multiple sites. Okay, like for example, you can have NO, right? A lot of questions are asked from the concept of NO. Then you should be aware of high spin and low spin complexes. Now it looks like it's a very trivial concept, but when it combines with other concepts, it becomes a really challenging question. So you should be aware of what exactly the ligands are going to do, and because of that ligand, whether that complex is going to be high spin and low spin. So that is something you should always be aware of. That is that when you are basically doing coordination chemistry, whenever you come across a coordination compound, just think of the ligand that is attached, and just try and memorize that whether it is it will act as a high spin or a low spin complex. That is something you should keep at the back of your mind. Then magnetic moment, again magnetic moment seems like a very trivial topic, but then sometimes magnetic moment is asked with respect to EPR. Okay, so then you need to find out, okay, how many unpaired electrons are there, and that question will be combined with your EPR spectroscopy. Then magnet water exchange, orbital contribution, pi acceptor, sigma donor ligands. Uh, a lot of questions you will see from transition metals, right? 3D, 4D, 5D. A lot of questions are there from transition metals. Now, you need to know the electronic configuration of the transition metals. Questions could be, okay, among these transition metal complexes, which will act as the best reducing agent or which will act as the best oxidizing agent. Or they can ask you questions within a group as well. Okay, within a group as in like let's say you have a 3D metal, a 4D metal, and 5D metal belonging to the same group, and they can ask you the rate of oxidation or reduction of those coordination compounds. So those are some of the questions that you should keep again at the back of your mind. Then crystal field stabilization energy, giant Taylor distortion. Like I said, most of these concepts can be clubbed with spectroscopic techniques like EPR spectroscopy. And then color and spinels has not been asked. Color means color in coordination compounds. How do you find the color, and how does the color change with respect to the crystal phase stabilization energy or the splitting of octahedral complexes? So that is something that you need to keep in mind. And then spinels is something again that has not been asked since a long time, so that is something that I expect these two topics you might see in the coming examination. If I talk about organometallics, so reaction mechanism of obviously most of you are aware of, which involves oxidative addition, reductive elimination, beta hydride elimination, migratory insertion. Okay, but there is an obsession with iridium complexes. So most of the questions that I've seen over the last 8 exams, all of them in fact had a iridium complex which was playing the role of a protagonist. So that means iridium complex was playing a central role in all of these questions. So whenever you are practicing organometallics, what you could do is focus more on iridium complexes. Whatever reactions are given in books, okay, you should focus on the iridium complexes. Then this is something that I've highlighted because I have seen that they have not asked a lot of questions from this concept. That is how the oxidative addition and reductive elimination varies within a period and within a group. Okay, so that is something that you should be practicing. It is given really well in VD Gupta. Okay, this is the book that I generally recommend for organometallics. Then in organometallics, you also need to do catalysis. This is something that is frequently asked, like hydroformylation, Wacker process, Monsanto acetic acid process, Cativa process. Then 18 electron rule. This is simple, but then again, you should know the contribution of ligands in the 18 electron rule. Particularly, questions are asked with respect to number of metal-metal bonds that can be formed, and also with temperature. So, for example, there's a complex which follows the 18 electron rule, but then if you increase the temperature, then what structural change might happen? Okay, so this can be combined with the property of denticity, or it could be combined with hapticity also, this 18 electron rule. Then metal carbonyls, super important. Each and everything about metal carbonyls you need to know in and out. A lot of questions do come and is very frequently asked. Then sometimes questions are asked with respect to the carbon metal bond length in organometallic compounds, or let's say alkene is coordinated to a metal. So there are different metals to which the alkene is coordinated, and they will ask you the CC bond length of that alkene, that where the CC bond length is going to be shorter and where longer. Then metathesis has not been asked, so this is something that I expect in this exam. Similarly, agostic and anagostic interactions is also something that I do expect. Hapticity and fluxional behavior are very important with respect to organometallics, and generally fluxional and hapticity, these concepts are combined with NMR. So hapticity is sometimes asked with reaction mechanism also, but fluxional is generally combined with NMR. This is something that has again not been asked, so you can prepare metal carbenoids. And like I mentioned, change in structure with temperature. How if you basically whenever you're doing something, you're reading something in the book, okay, you're doing some or you're reading some research article for that matter, just see if there's a mention of change in the structure with temperature. Basically, it forms a more stable structure with increase in temperature. So those sort of examples you should be particularly careful of, because that is something that can definitely be asked in the exam. Coming to F block, lanthanides and actinides. This is a small topic, but it has very high weightage in the exam. And the problem is that most of the questions that are asked from F block are like multiple select questions. So what they will do is they will ask you a question, and they will give you four statements: A statement, B statement, C statement, and D statement. And then they will ask which of the following statement is correct. So and the options will be like A and B, B and D, A, B and C. So it is so CSI does not have a multiple select questions like there are in GATE and IIT JAM exam, but they kind of make it into a multiple select question this way. So you need to be very thorough with F block, and they can ask you a question from anywhere. It could be from, first of all, you should know the electronic configuration. That is the most common. Then the magnetic moment, and how what is the orbital contribution, how to calculate the orbital contribution in magnetic moment, the oxidation states of lanthanides and actinides, the common oxidation states, how do you separate lanthanides and actinides, what are the kind of transitions that these lanthanides and actinides may show, whether it's going to be sharp or whether it's going to be broad, and the color of your lanthanides and actinides. These are some of the topics that you should definitely prepare well. Okay. Then structure is something that carries a lot of weightage. So I've labeled it separately because you can prepare, for example, isolobal questions based on isolobal analogy, isoelectronic structures, isostructural molecules. Okay, these questions are very common. Then Vesper theory and clusters. Clusters obviously is very important, like in the sense that categorizing it into nido, irachno, okay, those kind of questions, or maybe just finding out the geometry of the cluster. What geometry is it going to acquire? And in Vesper theory, you might think that this is trivial, but again, either a direct question will be asked from Vesper theory, like for example, four structures will be given to you, and they will ask you, okay, which of them have the same number of lone pairs, so that you can calculate through Vesper theory. And in general also, whenever you are doing organometallics and coordination compound, particularly whenever you are studying coordination compounds, whatever complexes, coordination compounds or coordination complexes you come across, try and predict their structure, or at least Google and try to find what structure do they adapt. That is super important. Okay. Then spectroscopy again carries a lot of weightage, particularly a lot of questions come from NMR and IR. EPR and MOSBAR, like very select examinations have these questions. Like hardly 2 or 3 exams in the last 8 exams that I analyzed had questions from EPR and MOSBAR, but NMR and IR is very important. So earlier what used to happen was questions from NMR were based on your 31 phosphorus NMR or 19 FNMR and satellite peaks. But questions from IR were only restricted to your CO, metal carbonyls. But now questions have started coming from your CN bond also. Okay, like if a CN ligand is complex with a metal, then what will be its IR stretching frequency? And very recently a question did come from SO bond, like sulfur oxygen bond also. So you have to not keep your knowledge limited to CO and CN, but also go for some other important ones, like for example SO is there. So if you come across any ligand which you frequently find in coordination compounds or in organometallic complexes, then just try and see what is the stretching frequency and how it might vary when it coordinates to the metal. Okay. Then these are some miscellaneous topics that you can do, like for example, if you want to do chemical bonding, but it's quite vast, you can just do, for example, you should know about the orbitals, like what orbitals are going to combine to form a bond. And even for coordination and organometallics also, whenever a bond is forming, you should be aware of the orbitals, what orbitals are leading to formation of bond. For example, in charge transfer, you should be aware, okay, if the charge transfer is taking place in a complex, then which orbital is transferring electrons to which orbital. That is something that you should be clear in your head. And then term symbols, again very important. And then there's a concept of non-aqueous solvents. I have a very detailed video on YouTube on non-aqueous solvents. So I think if you do that video, it's a 20-minute video that will be sufficient for you to prepare non-aqueous solvents. Generally a 4 marker is asked in the exam. Now coming to main group, bioinorganic and analytical, that is where a lot of confusion lies. So earlier in my videos, in my strategy videos, if you see from previous examinations, I recommend that main group should be left out because it is really vast, and I mean its weightage is not that great. It has weightage, but then it is very vast. Okay, but what I've seen is over the last 8 exams that a lot of questions come from group 15, that is the nitrogen family. Okay, so if you plan on preparing main group, then definitely do group 15. And then what I've seen in group 16, a lot of questions come from your sulfur acids. Okay, acids of sulfur. And then in noble gases, you can just do the reactions if you want. So group 15 and group 13 are very, very common. In group 16, most of the questions are from sulfur acids. And then in group 18, that is the noble gases, if you can do some reactions particularly related to xenon. I've seen most of the questions are related to xenon chemistry. If I talk about bioinorganic, well, in bioinorganic, you have to do hemoglobin, basically all heme not actually their name is heme, but they do not contain the heme group. So like hemerythrin, hemocyanin. Anyway, so the hemoglobin, hemerythrin, hemocyanin, myoglobin, and cytochrome P450. These are some of the you can say enzymes or proteins that you need to do in and out. What I mean by in and out is you should know about the structure, the metal that is present, how the mechanism operates, how the oxidation state changes, everything about them. Okay, these are most commonly asked. Apart from that, if you want, you like there have been questions from very limited questions from vitamin B12, ferridoxin, and then there have been questions from different kinds of enzymes, like for example xanthine oxidase, carboxypeptidase, carbonic anhydrase. Okay, but those questions are particularly very superficial, in the sense they will just ask you, okay, what is the metal that is involved in xanthine oxidase, or what is the role of xanthine oxidase. So if you just even read a couple of lines from Wikipedia, you will be able to answer those questions. So that is up to you whether you want to do these or not, like different kinds of enzymes. But this is something that you definitely should do, because most of the questions come from these 5 topics, that is hemoglobin, hemerythrin, hemocyanin, myoglobin, and cytochrome P450. Rest, if you want to do, you can go ahead and do that. Coming to analytical, one topic that has been very you can say common in the exam is nuclear chemistry. Okay, so if you are planning on preparing analytical chemistry as well, please do nuclear chemistry. Whatever sort of questions have been asked previously, just do all of them. This is very again, I'm using the word frequently a lot, but then it's okay. I think I'll have to improve my vocabulary anyway. So yeah, so nuclear chemistry is something that you need to prepare well. Apart from that, I've seen that in the last 8 exams, other topics from analytical chemistry have been very varied. There's no pattern to it. Like there was a one time a question from TGA, then a couple of questions were there in the last 8 exams from chromatography. Then in 2 of the exams there were questions from polarography, or atom absorption spectroscopy, or atom emission spectroscopy. So it has been very varied. But then if you do really want to do analytical, what I would suggest from my end is that nuclear is something that you have to do. Thermogravimetric analysis you can do, and titrations have been very common. But then titrations have been of different kinds, like for example amperometric titration, pH metric titrations, thermal titrations. So maybe you can do all analytical techniques related to titrations. You could do nuclear, you could do TGA, and you could do chromatography and polarography. These, I would say, have a higher chance of appearing in the exam than other analytical techniques. But if you have less time, then I would suggest you go only for the nuclear chemistry. So that was my analysis of the inorganic chemistry, and then through this you can formulate your strategy. Again, I would just like to remind you that I am having a live session tomorrow, that is from 9 to 11 p.m. Thursday. This is your 7th of July. Okay, so if you are interested, if you have any queries related to the examinations, you can ask me directly over there in the live session. Anyway, I hope you found this video helpful. If you did, please give this video a big thumbs up. If you haven't subscribed to the channel, please do that, because you are going to see more and more videos for the upcoming examination that is going to happen in September. And if you found this video helpful, please also share it with your friends. Thank you so much for watching. I'll see you in the next video with physical chemistry strategy very soon. Take care and bye-bye.
Hey guys, so I'm a verified educator on Unacademy, and along with that I'm also available on the Unacademy Plus platform, where I'm taking live classes along with other educators. So in case you're interested in attending the live classes, you can subscribe to the Unacademy Plus platform using my referral code, that is SETHI, and that will give you 10% discount. Alright, and in case you're not interested in attending the live classes, you can watch the free courses that are available on the Unacademy. For that, all you need to do is go to the Unacademy website or download the Unacademy Learning app and search my name over there, that is ACT. Once you do that, you will get the access to all the free courses that are available on the Unacademy platform. Alright.